Hello students, today I will teach you about some basic biomedical statistics or medical biostatistics. Okay, so we are starting with the data. What is data? Data is everything in statistics because there is no stats without data. Data can be any value that is measurable or countable. Any set of values can be data. So I will not go deep into this. We are directly going towards the topic that can bring you some MCQs here. Okay. So I can divide data into two parts like qualitative data and quantitative data. Qualitative data and quantitative data. And how to remember this thing? So we have one mnemonic NOIR, NOIR. NOIR means nominal, ordinal, interval and ratio. Nominal and ordinal are part of qualitative data. Interval and ratio are part of quantitative data. Here nominal means we are seeing that data is name based or norm based, means we can say male and female. It is a type of nominal data, it is a qualitative data. We can take yes or no. So there is no order in the data in nominal, but while in ordinal, data is in a specific order like mild, moderate and severe. Here one more thing, Likert scale is also a part of ordinal data. What is Likert scale? You must have seen in many surveys on internet the data when someone asks you strongly agree, neither agree nor disagree, disagree and strongly disagree. This 5-point scale, it is called Likert scale. There is no values, no numerical values. So this data is non-numerical data and nominal and ordinal is a part of qualitative data. Okay. Next we are coming towards quantitative data. We can say numerical data or measurable data. In interval and in ratio, divided into interval and ratio. And in interval there are a specific interval between two values like number of children. If we are doing a study on number of children of various families, if we get 2 children from a family and 3 children from other family, so there is a gap of 1. This is called interval. We can't say that there are 2.2 children or 3.2 children or 2.7 children. So there must be a gap of an integral. Like in ratio, we can have data in points, like we can take blood sugar level, it can be 121.5, like we can take weight, it can be 80.2 or like 81.2. Every possible value is possible between two different variables like 80 and 81. So weight can be 80.1, 80.01, anything between two variable is possible. So this data is continuous data, and this data we can convert it into ratio like 80.5. We can write it 805 upon 1000. We can convert it into the ratio. For temperature in Kelvin is ratio and temperature in centigrade and Fahrenheit is interval data. So we will discuss more about the data. I think You should take a screenshot of this. Now here is the full detail. So like I described you in last slide, qualitative data is categorical data or non-parametric. Either this non-parametric word I will describe about non-parametric thing later. There are some different things I have to tell you about this. And quantitative is numerical, measurable, parametric or dimensional. The old words are same. So in NEETPG examination, you might have a question that which of the following data is a quantitative data. In option, they can give you nominal, ordinal, interval, ratio, either interval or ratio, and one word from here, categorical, qualitative, non-parametric. Here your question will make like this. They can ask which of the following is not a qualitative data or which of the following is a qualitative data. So you have to learn this thing. Qualitative, N-O-I-R, nowhere. Qualitative and quantitative data. So like I told you in last slide, nominal data, names, there is no order. Ordinal, specific order, like mild, moderate, severe, like Likert scale. In interval, no absolute zero in the interval. This is the important thing, we have to learn this. No meaningful ratio. Here are the ratio, that's why we are saying that it's a ratio type of data, and ratio is the best scale of measurement. If we are having ratio data, we are having data in the form of ratio, is the best type of the data. Okay. Interval data is integral, countable, and best measure of nominal data is mode, because there is no numbers, there is no data in numerical form. Ordinal data is best measured by median, like in Likert scale. If we are having data like strongly agree, agree, neither agree, nor disagree, disagree, and strongly disagree. So middle value is the median. We can tell that median is the measurement of ordinal by median. We cannot calculate the mode or mean in this type of data. And for quantitative data, mean, median, SD, correlation, regression, anything you can calculate. For some example, nominal data, sex, race, community, region, like rural, urban, yes or no, blood grouping. So these are the nominal data. In ordinal, Likert, cancer, TNM staging is also a part of ordinal data. In interval, pulse, temperature, centigrade and Fahrenheit, number of the children. This is the type of interval data. And example of ratio are HB, BP, weight, temperature, blood glucose, and cholesterol. So few more things about data, that you might have been studied that data can be primary or secondary. Primary data, you get the data first and from the source. First data from the source. You are going directly to towards the subject, and you are taking data, you are collecting data from the subject. While secondary data, you are taking data, preformed data, already present data, like you are taking data from hospital records. This is secondary data. Other type of classification, dichotomous and polytomous. Dichotomous means data is in binary form, like yes, no, present, absent. This is binary data. And polytomous means non-binary. There may be much more values like mild, moderate, severe, like Likert scale, and interval and ratio. Now one more classification, discrete and continuous data. Discrete means both data are independent to each other, like number of children 2, 3, like age, like sex, male and female mutually exclusive. But in continuous data, this is measurable on a point of scale like weight. Any value can be possible between 80 to 81, but in number of children, no value is possible between 2 and 3. So there is a table of difference between discrete and continuous. No in between values, few possible values like gender, blood group, obesity, parity, number of children, and in continuous data large number of values like weight, height, BP, sugar. So we have studied this data in ratio, and we have studied this data in nominal, ordinal and interval. So this is all about data. Now we are coming on the tabulation of data, how to tabulate the data. So there are three type of tables I have shown here. Number one, simple table. We have taken particular sex in male and female, and we have taken number of anemic male and number of anemic female. This is the simple table. Now we have divided this frequency into distribution according to the more variables, like we have divided anemia in mild, moderate and severe. Now 120 male divided into 50, 40 and 30. So this is the distribution of frequency. So this table is called frequency distribution table. One more table are here in which frequency is written as a cumulative frequency, like 2, here 2, 2 plus 3, 5, 5 plus 5, 10. And we can calculate relative frequency by dividing this cumulative frequency from total frequency, and we can calculate relative frequency, we can calculate cumulative relative frequency. So this is cumulative frequency and this is the frequency. When we divide this frequency from the total number 2 by 10, 3 by 10, 5 by 10, we will get this data, relative frequency data. And when we divide cumulative frequency from this number, we will get cumulative relative frequency. So these are the table. With these tables are not so much important for the NEETPG, but I had to tell because this is a topic here. Now this is very important table for NEETPG examination. Here data can be represented in the form of graph also, and many times this questions in NEETPG have been asked from this topic, or in many other competitive examination this questions has been asked from this topic. Graphs can be qualitative data and quantitative data can be presented by the graph. And for qualitative data we have four type of graph: bar diagram, pie chart or sector chart, same name, pictogram and map diagram or spot diagram. So you can learn it by bar, pie, picto, map. You just remember this thing: qualitative data, bar, pie, picto, map; qualitative data, bar, pie, picto, map. So you have to remember this thing: bar, pie, picto, map. Bar, pie, picto, map is qualitative data. Now if examiner come with any type of question, if you learn this trick, you can solve the question. How? Examiner might ask, histogram is you can represent the data in histogram, following data like qualitative data, or in qualitative we have read nominal and ordinal, nominal data, ordinal data, qualitative data and interval data. Histogram can represent nominal data, ordinal data, qualitative data, interval data. So our answer will be interval data. Either can ask ratio. Similar question in frequency polygon, frequency curve, line chart, cumulative frequency diagram, anything. From qualitative data question may I ask, which of the following is not a type of graph representation by qualitative data? Option: bar diagram, pie chart, pictogram and scattered. So your answer will be scatter type of diagram. So you just remember these four things: bar, pie, picto, map. Bar, pie, picto, map is a graphical representation of the qualitative data. Next we will learn about these graphs. Rapid revision of all graph. Number one, bar diagram. Bar diagram is simple common diagram that can be vertical, that can be horizontal. In bar diagram is used for qualitative data because we have already studied that bar, pie, picto, map. These are for the qualitative data. You can say nominal or ordinal also. Vertical and horizontal it can be, ascending or descending it can be. Bar width of each bar should be equal and the distance between two bar minimum distance should be half of the bar width, and height of bar is show the frequency. Whatever the frequency, if frequency is high, the height of the bar will be high, and multiple bars can be drawn at a same time. Next, these are the different type of the bar diagram. This is the simple bar, this is a component bar, and this is the proportional bar. So these are the different, and we can also have a nowadays 3D diagram, 3D bar. Like this is pie chart. Pie chart is a very common graph, and this is also used for discrete or qualitative data. Here new diagram is Venn diagram. It shows degree of overlapping between pie chart. So you have to remember this thing. Venn diagram, it's a new one. Examiner can ask, examiner can give the image of this diagram and can ask which type of the diagram it is. Next, pictogram. What we do in pictogram is for the layman's, the people who do not understand too much about the graph. What we do here, suppose we have 4 groups A, B, AB and O. These are the blood groups, and frequency of blood groups, A blood group 25 people are having A blood group, 30 are having B, 20 are having AB and 5 are having O. So we have decided that 5 units of variable is equal to star. We have made a star here. 10 group we have made a heart here. For 10 group we have made plus, and for 1 group we have made something like a diamond. So for layman we can draw the data like this. For A blood group we have to make 5 star, not the chocolate, this is the 5 stars. And for B, because 10 is the unit of the variable, so we will make 3 hearts here. For C we will make 2 plus here, and for D we will make 5 diamonds here. So this is the pictorial presentation of the data. This is for layman only. So examiner, if I am not very much sure that this will come in the exam, but if examiner will ask which type of graph can be used for the layman purpose, for educating the layman or for presenting the data for layman, in exam in option he can give bar, pie, picto, map. So picto is the answer. Next, this is the map diagram or spot map diagram. In map diagram you can take the map of whole country, and in spot map you can take area spot map. This is the same area, this is not the same area spot map which is developed by John Snow for cholera distribution, but he also made a area spot map for the for investigation the epidemic of cholera. So I have told in previous lecture about this. Next is histogram. So now from here quantitative data has been started. Histogram, there is, now you are seeing that no gap between the bars of histogram like the bar diagram. It is histogram. Histogram is generally normally distributed like this is, but it can be positively skewed deviation and it can be negative skewed deviation. If value of the mean, median and mode are equal, that will be normal distribution. I will teach you about this later in similar today's lecture. In right skewed deviation or positive skewed deviation, mean is greater than median, median is greater than mode, and in left skewed deviation, mean is lesser than median and median is lesser than mode. So this is the histogram. In frequency polygon, what we are doing in frequency polygon, we are just adding the, in frequency polygon we are just joining the midpoint like this. One minute. Yes. So in frequency polygon, we are joining the midpoint of upper part of the histogram and we are making a line diagram. We are making a line, creating a line. So this line will be called frequency polygon and it will cover the area under the curve. Now I can say, if I may ask, in histogram, the area under the curve, how can we calculate area under the curve? We can calculate area under the curve by multiplying height and width of each column and now adding all value a plus b plus c plus d plus e plus f g h all. So we can calculate the area under the curve in histogram like this. So we have gone through frequency polygon. Now this is the frequency curve. What is frequency curve? So frequency curve, when there are so many variables, the number of variables are too much. The frequency polygon, what we have studied in the last slide, frequency polygon will lose the angulation and a straight line, a curved line will present like this. There is no angulation like this, no angulation. This is the curve, like it is frequency curve, and we can also calculate area under the curve in this frequency curve. So a smooth curve will be made when data is multiple, there are too much variables, so there will be less width of the histogram. Now this is the line chart. Simple, one question can arise from the line chart. This it is used to show the trend of event, and it can compare 2 or 3 variables also, like this. The green line shows that one variable is increasing with the time. This blue line is showing that trend is increasing with the time, but red line is showing that trend is decreasing with the time. So there are the comparison between the variables also, but there are it is showing trend. So question may arise, the line chart is shown to like why line chart is used? Line chart is used to show the trend of event. Now cumulative frequency diagram is called ogive. This is the direct question examiner may ask, what is ogive? So ogive is used to cumulative relative frequency diagram. Next is scattered or correlation diagram. It is important diagram. We will study 2 things from here. One is in scattered diagram or dot diagram or correlation diagram, we are representing data in the form of dot. If a straight line, we draw the straight line and line is increasing, so we can say this is the positive correlation. If line is on downward trend, it is negative correlation, and there is no line here, there is no correlation. Here we can say positive correlation showing by +1, here negative correlation showing by -1. So in correlation, the value of correlation coefficient, that is R, from +1 to 0 to -1, the value will oscillate between +1 to -1. There is never a value more than 1. This is very important because examiner will ask you in exam that if maximum correlation between 2 variables is shown in which option? Number 1 -1, number 2 0, number 3 1, and number 4 2. And by mistake we will see 2 is the largest quantity, so we will write the answer 2, but answer will be 1 because 1 is the maximum value in the correlation. But in the odds ratio, answer will be 2. So you have to keep this thing in mind, that value of correlation coefficient maximum value is +1. Next, quartile range. Oh no, not quartile. This is the box and whisker plot, and it is based on the quartile range. So when I will teach you about quartiles, I will repeat it again. What happen when we divided data in 4 quartiles. So there are 4 parts, but quartiles will be 3. Always number of quartile will be 1 less. If we will divide into 10 deciles like 1, 2, 3, 4, 5, 6, 7, 8, 9. So there will be decile will be 1, 2, 3, 4, 5, 6, 7, 8, 9, but parts will be 10. If we will divide in percentile, so percentile is 100, part will be 100, but percentile will be maximum 99. So you have to keep this thing in mind. Here we are dealing with the box and whisker plot. Here largest value Q1, Q2, Q3 and the smallest value, these are the 5 measures that we needed to make a box and whisker plot or box plot. Q2 is always equivalent to the median. This is the value of median. Now next one is stem and leaf plot. It is also a new type of questions that are asking in exam nowadays. It's very simple thing. In stem and leaf plot, what we are doing, we are breaking down the number. Like we have a number 429. So 42 is stem, 9 is leaf. We have 32, 3 is stem, 2 is leaf. We have 5, 4, 3, 2. 5, 4, 3 is stem and 2 is leaf. Okay. So if we are having data number of books read by the 10 student, 12, 23, 1, 19, 6, 10, 7, 15, 25, 21, 23. What we are doing, we are identifying first stem. Stem is 1, 2, again 1, here 0 because 0, 6. Here 1, here 0, 1, 2, 2, 1. So only 3 stems are here, 0, 1 and 2. So we will write in ascending order 0, 1, 2. Now in first stem is 2, second value is 23, for 2 stem value is 3, for 19 next value is 9, for 6 because it is with stem is 0, so it is 6. Next 10 means here 0, 7 means here 7, 15 we have put 5 here, 25 now 5 we will mention 5 here, 21 for 21 we will mention 1 year, and for 12 we will mention 2 year. So this is the stem and leaf plot. Now this is a spider map or a radar map. You just remember the this is used for multivariate type of data, for displaying of multivariate data. You just remember the image because examiner may give this image in exam, and examiner may ask which type of graph this is. So you have to keep this in mind that it's a radar or spider chart. Next is Pareto diagram. In Pareto diagram there is 2 things, one is bar diagram, one is line diagram. Bar diagram is in descending order and line diagram is in cumulative frequency. So 2 things here in Pareto diagram. Next one is tree map. Tree map is nothing, it is just showing the hierarchy of any organization, hierarchy of any examination. Like if a patient is coming to a hospital to see a physician will examine a patient, like he will examine physical examination, he will do of respiratory system, then before respiratory CNS system, respiratory system, then abdominal or GIT system and cardiovascular system also. Now if he find anything in abdomen, if he find anything and he asks a reference of gastroenterologist or a nephrologist, patient is having a palpable mass. So palpable mass can be due to gastric problem or due to nephrotic problem. Both are in the abdomen. So here we are seeing that a tree is formed like this. Okay. a question have been asked in NEETPG about this. A patient went to a doctor and doctor examined him for diabetes. Now he is examining him for joints. So what will be the map? So map will be tree map. Next is sample size calculation. Sample size calculation, we can estimate the sample size for qualitative data differently and for quantitative data differently. For qualitative data, formula is 4pq1 L square. Here P is prevalence or proportion, Q is 1 minus P or 100 minus P if given in the percentage form, and L is allowable error, which is 10 to 20%. For quantitative data, formula is 4 SD square upon L square. SD is standard deviation and L is allowable error, absolute error, which is 5%. Here one thing, if allowable error is, we decrease the allowable error, we will get more sample size. It means if we want more accurate data, if we want less error, we have to increase the sample size. Next one, yes, this is showing the sampling types. So I will cover all the sampling in this slide only. So there are two types of sampling. One is probability sampling and another is non-probability sampling. In probability sampling, there are 6 types of sampling. Number 1, simple random. Simple random, we are doing nothing. We are just randomly selecting the people from population. We are randomly selecting the study population from target population, like a lottery method, like from a random table, random number table, like from a random number table, from lottery, from taking a card, like anything. So even we can distribute the patient a number in ascending or descending order and randomly calling the patient by striking a dice, striking a coin, anything like lottery. In systematic sampling, what we are doing, we are arranging data, arranging the population in a special ascending or descending sequence, mostly in ascending sequence, and first number we are selecting randomly. Next we are taking either every 7th, every 10th, every 12th. Suppose we have population of 400 people and we want 40 samples. What we will do, 400 divided by 40 means 10. So we can take every 10th. So first person we randomly take, suppose second person we are taking. So next will be 12th, next will be 22, next will be 32, next will be 42. So this is called systematic random sampling or systematic sampling. For stratified sampling, what we are doing, we are grouping the patient, we are making strata of homogeneous population, like we have make strata of gender, male and female. We have make data of age group, like child, old age, young age, adult age, like this. And we will select the patient, select the population, select the sample by random sampling from that strata. All strata will be taken here. Like we have made 5 strata, we will use all 5 strata for our sampling, and we will for individual strata, like we have made strata of male and female, and we need 40 patients from each, 40 samples from each. So we will take here from by random sampling. So first we will make strata and then use random sampling. While in cluster sampling, generally we will do cluster sampling for geographical region. We will make clusters, like we make 30 cluster of colonies in a city, and from 30 we are selecting only 7 or 8 or 10 cluster, and in 10 cluster we are doing random sampling. So the difference between strata and cluster is this: in strata we are using all stratas for our study, but in cluster we are not using all clusters for the study. Then next is multi-stage sampling. Multi-stage sampling is done for large population, like we have suppose we have 100 countries. From 100 countries we are using one country for our study. In one country we have different 30 states. From these 30 states we are using 3 or 4 states for study. From these 3 states we are using 30 to 40 districts, and from district we are using village. So they are the study is designed on different stages. So it is called multi-stage sampling. And next is multiphasic sampling. In multiphasic sampling, what we are doing, we are screening at different level. Like in patient of HIV, first we are screening for ELISA, and the patient who is positive will be tested for Western blot. So this is the multiphasic sampling. While in non-probability sampling is not a better type of sampling. Probability sampling are good. Non-probability sampling, like consecutive, we select all population till we get our desired sample size. Convenient sampling, conveniently we are taking population from available, accessible or present population. Like patients are coming to our hospital and we are using all these patients for our study, so it will be convenient sampling. Quota sampling, what we are doing in quota sampling, we are dividing population in different strata, like we have done in the stratified sampling. But here, after dividing into strata, we are not taking randomly, we are taking by our convenience or by consecutive. So here it is called stratified but non-random, and this was stratified but random. This is the difference. Next, purposive sampling, we are taking the sample size purposely, intentionally. And one is snowball sampling. Snowball sampling is very important. It is also called tracker or refer chain or contact tracing, like we have done during the COVID period. So when it is difficult to identify the participants, what we do, we just grab the one participant and ask him to make a chain. Like we are doing IV drug users, we are taking a study participant IV drug user, and we are asking about his friend who is giving them company. So that will be our second study participant. In COVID, what we were doing, we were taking a patient who is COVID positive and we were asking about the contact history. So that thing is called snowball. Why snowball? Because from a mountain, a small snow piece, when rolling down, it will bigger and bigger till it descend. So it will make bigger. Why it will bigger? Because it will incorporate more ice and ice. So in snowball sampling, what we are doing contact tracing. We will catch first study participant. By contact tracing, he will tell about his 3 or 4 contact, and each contact will tell about more contacts. So our sample will be increased with time. So that's like snowball. Okay, so these are the different type of sampling. Now measures of central tendency, there are 4 measures of central tendency: mean, median, mode and quartile. What is mean? Mean is simple arithmetic mean. Like we have data 2, 4, 6, 8, 10, 12, 14. So if we add 2, 4, 6, 12, 2, 4, 6, 6, 6, 12 and 20 and 30, 42, it will 56. Total will be 56. So what will be the mean? So there are total 7 values. We will divide 56 by 7, the value will be 8. So 8 will be our mean. Okay, it's very simple. But mean, we cannot calculate mean for qualitative data, because in qualitative data we do not have numbers. We have numbers only in quantitative data, so we can calculate mean for the quantitative data only. And what is median? So median is arrange the data in ascending order like this or descending order and catch the mid value. So that here 7 variables, so we divide n by 2 and add plus 1. 7 by 2 plus 1, is it possible? No, n minus 1 by 2, 7 minus 1, n plus 1 by 2, 8 by 2 is equal to 4. Fourth value we will take. This is, so you left initial values, last values, the center value will be our median. So here mean and median both are 8. Now what is mode? Mode is most frequently occur number. Here nothing is most frequently occur, so I am changing the data. What I am doing, I am writing 11 here and 11 here. Now totaling will be 56, so mean will be 8 and data is in ascending order, median will be 8, but mode is 11. Why? Because it occurs twice here, so mode will be 11. Now if I change 14 by 40, okay, so what will happen? Mode will not change, because in ascending order 2, 4, 6, 8, 11, 11, 40, 8 is the mid value, so median will be 8. So median does not, median is not changing with the extreme value or change in the values. Mode will not change, because 11 here, 11 is the most repeated number, so mode is also not changing with the change in the data. But mean value will change, because we have to add 26 more here, mean value will change. So what I want to say, that mean is affected by the extreme values, median and mode are not affected by the extreme values, but mode can be affected if I will replace 11 by 40. Okay, if I will replace 11 by 40, then mode will replace, or I can change 11 by 14. So what will happen? Now 14 will be the most occurring number, so mode will be 14. So by changing the extreme values, median will never change, mode can change if change in the mode value, and mean will always change. And what is quartile? Now I will tell you about the quartile. Okay, one more thing I forget to tell you here. You can calculate mode by multiplying 3 with the median minus 2 into mean. If in exam one question is giving you median value of 4 and mean value is 3, how to calculate mode? 3 into 4 minus 2 into 3, 12 minus 6, 6 will be the mode. Okay, remember this thing. Now what is quartile value? So I already told you about in box whisker plot. In quartile value, we are dividing the value in 4 different parts, 1, 2, 3, 4 by 3 quartile. The middle value is called median, and this is the lower quartile, this is the upper quartile. If we want to calculate the interquartile range, Q1 to Q3, Q3 minus Q2, Q1 will be interquartile range. Okay, and 25%, 25%, 25%, 25%. Each part accumulate 25% of the population. So anything, if examiner asks, if we have 200 populations, so we have 50 population here, 50 here, 50 here and 50 here. If examiner is asked what is outlier of the Q3, that will be 50. What is the interquartile range? That will be 100. What is the outlier of Q1? That will be 50. And median, from median 100 is here and 100 is here. So median divide the quartile in 2 equal parts. Okay. Now these are the measures of dispersion. We have calculated mean, mode, median. So now we are calculating the measure of dispersion, measure of variation. So number 1 is the range. In data like 2, 4, 6, 8, 10, 12 and 14, 12 is the minimum value, 14 is the highest value, to 2 to 14 is the range. Okay. For interquartile, I have already told you about the interquartile in last slide. Next is mean deviation, deviation from the arithmetic mean. Like 2, 4, 6, 8, 10, 14, we have calculated the mean value for this was 8. So we have 2, 4, 6, 8, 10, 12, 14 and mean value is 8. So deviation of this data 2 minus 8, 4 minus 8, 6 minus 8, 8 minus 8, 10 minus 8, 12 minus 8 and 14 minus 8. So mean deviation for this will be minus 6, for this minus 4, for this minus 2, for this 0, for this plus 2, plus 4 and plus 6. So this is the mean deviation. If we will do square root of the mean deviation, we will get standard deviation, and if we will do square of the SD, we will get variation, your variance, and coefficient of variance is calculated by SD upon mean multiply by 100. So examiner may ask this question, SD into 100 by mean, we can calculate coefficient of variation by this. Next is normal distribution curve. I have already told you about this in histogram. This is the normal distribution curve. This is the mean value. This is mean value. This is the standard deviation. If mean, mode, and median are equal, the distribution curve will called normal distribution curve or Gaussian curve, which is bell-shaped, symmetric, and unimodal. Area under the curve will be 1 or 100. 1 or 100. If we are taking in the percentage, it is 100%. Right skew deviation, this is the right skew deviation, this is the left skew deviation. When we will call right, when mean is greater than median, which is greater than mode, and if mean is lesser than median, which is lesser than mode, it is called left skewed data. So some things I will tell you later in this slide about the skewed data. Here it is very important for exam. What is this? This is the mean value. If we are having plus 1 SD data, plus minus 1 SD from here to here, 68% population will fall in the plus minus 1 SD, 95 population will fall in plus minus 2 SD, and 99% population will fall in plus minus 3 SD. Okay, so examiner is asking, if examiner is giving you mean plus SD and he is asking how many percentage of population will fall in this criteria, so he has given mean plus 1 SD, he has not given mean plus minus 1 SD. Okay, you have to check this. If examiner is giving mean plus 1 SD, it means he is asking about this value only, not about this, because here is the minus 1, here is minus 2 and here is the minus 3, here is plus 1, here is plus 2 and here is the plus 3. So if examiner is asking mean plus 1 SD, it means he is asking for 34% of population. If examiner is asking mean plus 2 SD, it means he is asking about 47.5% population. So when you read the question, you read it meticulously, carefully. Okay. In next question, 60% like this, 68% of the data, then 95% of the data, then 99.7% of the data. Okay. One more thing is here, kurtosis. What is kurtosis? Kurtosis is a new topic which is used for extreme values. For extreme values, if there is data is normally distributed, kurtosis value will be 3 and it is called mesokurtosis. If kurtosis value is more than 3, it means heavy peak or positive data, it is called leptokurtic data, and if kurtosis is less than 3, it is lower peak or negative peak data, it is called platykurtosis. So if kurtosis is high, means data is having high extreme values. If kurtosis is low, data is having low extreme values. You just remember this figure of 3. If more than 3, lepto, less than 3, platy, MLP, 3 more than 3, less than 3. So it can come in exam because it is a new topic. Now we are coming towards the Z score. Z score is calculated for normally distributed data to check the test of significance. And what we are doing, we are calculating Z score by calculating observation minus mean upon SD. Suppose we in a group of 500 students, we are getting mean value of weight is 60 and SD is 5 kg. So giving the observation of 75 kg. So 75 minus 60 upon 5, 15 by 5 is equal to 3. Value of Z score will be 3. And now we will see the table. If in table which is given in the book, or it will come in the exam, they will give the table. If they will ask this question, they will give the table. So if the Z value of Z score 3, the observed value or calculated value is more than the tabulated value, then data will be significant. So this I need to clarify, only p value is the thing in which value less than 0.05 is considered significant. In other all tested like chi-square, like z-square, like critical value, like standard error, in everything, if actual value is more than the tabulated value, then data will be significant. But only in p value, lesser values will be called significant. Okay, now we are coming on the test of association. So you will remember this easily. For qualitative data and for quantitative data, there are different type of test of association or significance. Qualitative data we have divided into nominal and ordinal and interval and ratio. What we are doing here, if for qualitative data we are use only chi-square, either variable are 2 or more than 2. For quantitative data, if variables are 2, we are using t-test. If variables are more than 2, we are using ANOVA. Okay, it's very easy to understand this thing. And in t-test there are two types of test, single t-test and paired t-test. In single t-test, what we are doing, we are having two different group A and B, and we have prescribed a new medicine to A group and a new medicine to B group, and we are comparing data of both the group. But in paired, what we are doing, we have same group A and we are taking readings before giving the drug and we are taking readings after giving the drug, means pre-test and post-test. So this is called the paired data. This paired t-test will be used here. So this is the test of significance or test of association like this. Usually test of association word is used for the qualitative data and test of significance word is used for the quantitative data. Okay, next here more detail about this thing what I have described in last slide. Okay, for categorical qualitative non-parametric data, if we have two groups, we can use chi-square, we can use McNamara, and we can use chi-square with Yates correction. These all things are same because chi-square, you know, what is chi-square? McNamara, when we are using 2 by 2 table of chi-square, 2 by 2 contingency of chi-square, it is called McNamara test. So McNamara test is also chi-square. Chi-square is Yates correction. Chi-square with Yates correction, it is called Fisher test. When it is used, when the number of tables are less than 20 or in any value in between in these four values is less than 5, we will use Yates correction. So this is also chi-square, this is also chi-square, this is also a chi-square. So test of association in categorical for two group is chi-square. Here if groups are more than 2, we will use chi-square and chi-square with Yates correction. One thing is here extra is Cochrane alpha. So Cochrane alpha we are using for qualitative data when variables or groups are more than 2. For numerical data, either 2 group or 3 group, we are using either Pearson correlation when data is normally distributed or Spearman rank correlation when data is skewed data. So we have these type of test of association. For test of significance, for 2 group we are using z-test, odds ratio or relative risk. For more than 2 group we can calculate z-test, odds ratio and relative risk. For numerical or quantitative data, we can use when group are two, we are using single t-test, paired t-test or z-t-test. When group are more than 3, we can use ANOVA, post hoc test, Tukey's test, Bonferroni for unpaired. And what is this? What is this? It is very important thing. In books you will read that Mann-Whitney or Wilcoxon rank sum test, both are same. Mann-Whitney or Wilcoxon matched pair test or Kruskal-Wallis or Friedman test, these are the non-parametric tests. And if these are the non-parametric tests, they should come in the qualitative. Okay, but what they are saying that mean and SD are the parameters of normal distribution. Okay, so if when we are not having normally distributed data, we are having skewed data, we will use these tests. So these tests will be called parametric because they do not have mean and SD. So we can do two things. Either we can convert this skewed data into the normal distribution and use single t-test, paired t-test, z-t-test, or from here, if more than 2 group, we can convert the skewed data into normal distribution data and use ANOVA or post hoc either. Or if we do not want to convert the skewed data into the normal distribution data, we can directly use these type of test. If there are 2 groups, we can use Mann-Whitney, which is also known as Wilcoxon rank sum test, or we can use Wilcoxon matched pair test when groups are paired. And if groups are more than 2, we can use Kruskal-Wallis rank sum test or Friedman test. So this is the totally this is about the different type of the tests. Okay, in next slide, what is chi-square? Simply it is given by Carl Pearson. It's a test of association. It's very important. Chi-square is not a test of significance, it's a test of association. We can use chi-square at anywhere. We can usually it was started for the qualitative data, but chi-square we can also use chi-square for quantitative, but it is primarily it was started for the qualitative data. And for quantitative data we have already so many other tests like t-test, we have ANOVA, so why we will use chi-square. And the value of chi-square, we will calculate the value of chi-square, and value of chi-square, if value of chi-square is greater than the tabulated value, our data will be significant. Okay, and for it can be used for 2 group or more than group. 20 if it is more than 20 groups, we can calculate by chi-square. If it is less than 20, we can use Yates correction of Fisher test. So I have already told you in last slide. What is degree of freedom? Degree of freedom is nothing if it depend upon the number of tables, number of rows and number of column. Like in this table we have 4 row, one first row, second row, third row and fourth row. Column are 4. So what we are doing? We are doing C minus 1 multiply by R minus 1. Column minus 1, row minus 1. 4 minus 1 is 3 into 3. 3 into 3 is 9. So 9 is the degree of freedom. The value of chi-square is also depend upon the degree of freedom. Okay. Observed value must be greater than the tabulated value for significance. I think this is the last slide among the last second last slide. Test of significance. We can use test of significance by comparing the sample mean with the proportion population mean by critical ratio. We can compare 2 sample mean by z-test. We can compare the sample proportion with population proportion by z-test, and we can compare 2 sample proportion by t-test. So we usually calculate standard error of mean, standard error of proportion. You will study in detail. In theory is this thing about this, and this is the test of significance. What is null hypothesis? Very important question. So when we are studying, you know, it is very easy to it is very difficult to prove the things true. If you want to prove something true, you have to place so many evidences, but to prove something false is easy. So what we are doing, Suppose we are doing a study on two drugs. Drug A is old drug and drug B is new drug. Okay, what we want that B drug is better and B drug is drug number B is better than the A drug. So what we are doing, we are making a null hypothesis. Null hypothesis what saying there is no difference between mean of both groups. Means there is no difference between the treatment outcome of A drug and treatment outcome of B drug. There is no difference. This is saying null hypothesis. If null hypothesis is true, it means there is no difference. Means our hypothesis, our study is rejected. Okay. Alternative hypothesis what saying there is actually a difference between both the group. If it prove yes, if we prove alternate hypothesis is true, what will happen? Our study is good because it is actually showing a difference. Okay. So what we are doing? We are calculating p value. P value means alpha value. If alpha value is less than 0.05, what we are doing? We are rejecting the null hypothesis and accepting the alternate hypothesis. It means there is a difference. If we are rejecting the null hypothesis, if we are accepting the null hypothesis, there is no difference. But we are rejecting the null hypothesis means there is a difference between A and B. It means we can use this drug. Okay. If p value is more than 0.05, we are accepting the null hypothesis and we are rejecting the study, we are rejecting the drug B. Okay. Now we are coming with the type 1 error. What is type 1 error? We have rejected the null hypothesis by mistake, by calculation mistake. By calculation mistake what we are finding? By calculation mistake we are finding the alpha value is less than 0.05 and we have rejected the null hypothesis. By rejecting null hypothesis what we have done? We have proven the study. What we have proven the study? That B is better drug. Now if we do type 1 alpha error, alpha error, we will reject the null hypothesis, we will prove the study and we will introduce the drug in the market, and when drug will come in the market or test will come in the market, it came by mistake. So there will be error and this error will be big because a new drug will affect so many public. In type 2 error, what happened in type 2 error? We accept the null hypothesis, means we are saying there is no difference, either there is a difference or there is no difference, but we accept the null hypothesis. What we are doing? We have rejected the study and we are not introducing the drug into the market. What will happen? Okay, nothing will happen because no new drug will be here because there are other drugs also here. So people will not affected. But if we do type 1 error, alpha error, people will affected by new drug. So type 1 error is bigger error than the type 2 error. Okay, one thing is also here, power of test. It can calculate power of test by 1 minus beta. Okay, so this is all about the basics about medical biostatistics, and I hope you will you can do all type of MCQs by reading this lecture. In next lecture what we will do? We will do around 200 to 250 MCQs of previous year questions and previous year MCQs, and you have to study. What you do? You just read this PPT and read this lecture, go through this lecture carefully, and in next lecture we will do around 200 to 250 MCQs. So this will cover up all of your biostatistics syllabus. Okay, thanks.